Our question here is, given a chessboard of size n cross n. So we are given a chessboard of size n cross n. We have to find all the ways to place n queens so that they don't attack each other. So let's understand the question. So here there is a 4 cross 4 chessboard and we have to place 4 queens in it such that no two of them attack each other. So let's see the configuration 1. So here we see that no one is attacking in this column here, so all are in different columns, so they are fine. They are in different rows, so they are not going to be attacked, and then diagonally also they are not cutting each other. Okay, so this is non-attacking configuration, it is fine. But let's see this one here. These two are on the diagonal, they can cut each other. These two are also in the same column, so they can cut each other, so they are attacking. So this is a attacking configuration. So how to solve this problem? And there can be multiple such solutions, so we have to print them all. So let's see first that what we mean by valid placement or non-attacking placement. Okay, so we want to see non-attacking placement, and here it is. So we have a 8 cross 8 chessboard here with 8 into 8 is equal to 64 columns, cells. Okay, so when can two queens cut each other? So we have to place here 8 queens. So queens are placed, let's say one is at I comma j, which means ith row and jth column, and another one is kth row, lth column. So they can attack each other if I is equal to k. That means they both are in the same row, like this one. So they are at 1 comma 2 and 1 comma 5, so they have same row. Similarly, what can happen is they can have the same column like these two. So it is 3 comma 2 and 5 comma 2, so they are having same column and so they can attack each other. Now a little tricky one is how to find the diagonal. So diagonal can be like this orientation, left to right and from and this way. Okay, so these two ways are there, and if we see, so we will find that here like this is 3 comma 6 and 5 comma 8, so they have like I minus j, I minus k, the absolute value of this is equal to j minus l. So which is the absolute value of difference between the x coordinates and the y coordinates. If they are same, so this is a attacking configuration. So this is diagonally they can attack each other, and these are the 3 ways in which queens can attack each other. So we have to see that okay, when 2 queens are placed at their respective places, cells, so they are not satisfying any of these 3 criteria. So the code, we will have a helper function bool place with k comma I, where both are integers, k and I. So k tells that it is the row, it returns true if q can be placed at kth row and in the ith column, and we have a global array x, so which maintains xk is a global array with first k minus 1 values already set. And what happens, like if we have x of 2 is equal to 3, so this means that in the second row of the chessboard the queen is placed at the 3rd column. Okay, so what we need to do is that we have that global array and we check here for j is equal to 1 to k minus 1. So we are checking all in the chessboard. So like we have a chessboard, so we already have, so we will check for all corresponding rows from 1 to k minus 1 and check if xj is equal to I. So it means what? we are trying to place in the kth row, and j we will try from 1 to k. These are all the, so we will be going from here like this, j is equal to 1 to k minus 1, and we will try to place what, so I will try to see, can I place a queen at k comma I. So I will check it with xj with I, and if any of the xj's from 1 to k minus 1 is equal to I, it means they are in the same column, so it will attack. Okay, so that will be something like a q here, and I'm trying to place here, so they will cut. I will check here also all the way from top to the k minus 1 rows. Okay, so I will check for all of them if it is attacking, or otherwise I will see based on the formula we saw, mod I minus k is equal to mod j minus l. So if this is also being followed, then they are on the same diagonal, the elements. So we are checking all the already placed queens in row 1 to k minus 1. So if they are in the attacking position, we return false, but if none of them are at the attacking position, we return true. So this now tells us that can we place a queen at kth row and ith column, and if we can, it returns true. So let's see. So this is the recursive function, the backtracking method, which sees all the possible values. So here what happens, I will call n queens, and I will call from row 1, and n is the value, so n is 4 or 8, something like that, a chessboard, and I will call here. And what happens now, for I is equal to 1 to n, so it will try to place the queens in each of the rows. Okay, so x here represent, x1 represents the column where the queen is placed in the first row. Similarly, x2 represents the column where queen is placed in the second row. So we say that all the queens can have to be, all the n queens have to be at least placed in different rows, otherwise they will attack. So that's why we have just one dimensional array. Okay, so for I is equal to 1 to n, so what we do, if place k comma I, can I place in the kth row and in the ith column? If yes, so I put what, I put x of k in the kth row, I am placing it in the ith column. And now what I check, if k is equal to n, so if I have placed the queens in all the rows, then I write the configuration that okay, what are the placement of the queens. Otherwise what, I have placed in the k rows, so now I will call n queens k plus 1 comma n. So it means I will be calling for the next row, to place the queen in the next row. So let's see how this works. So what we have is, so we will be starting here and try to make a systematic rule. So what I do, I will call n queens, so 1 comma 4 here, because n is 4 into 4 chessboard we have. So for n queens 1 comma 4, what we do is, so first we try to place here the first queen. I am moving from this way, I am trying all the possibilities. So first we make x of 1 is equal to 1. Then what I do, I call n queens 2 comma 4. Now again I will try here. So if I place, so here I will call place, what place, I will first try in 2 comma 1. So here I cannot place because it will be cutting in the same column. Here I cannot place because diagonally it will cut, so I can place it here. So this will be in the second row. So now x2 becomes 3. So what happens now, I will call n queens 3 comma 4. So what happens, it comes here, it tries this place, it will be cut in the same column, so it will cut here it will be cutting diagonally, here it will cut same column, and here also diagonally, so I cannot place it here. So what happens, I tried all the possibilities, and then for I is equal to 1, 2 and I tried, then I return back to my previous calling function, which is I come back here. So what happens, I will try this next place. I will make now x2 is equal to what, so I try here. So now x place k comma I, so still I can place it here instead of this one. So this one is removed, and so here it becomes x2 is equal to 4, and it can be placed here. So what happens, it can be placed here, x2 is equal to 4, and now I again call n queens. So now I call 3 comma 4 again, but it will start afresh, and here I cannot place, but I can place here. So x of 3 will be equal to what, x of 3 will become now 2, and now what happens is I can call n queens. So I cannot place here, I could have placed here, so I call n queens 4 comma 4. So I try this place, not possible, this one not possible, same column, here same diagonal, same column, so nothing is possible. I return back here. Now what happens, it will try the next thing, x3 is equal to 3, so it cannot be done, not valid, and then this one also not valid. So what will happen, it will come here, this was also not, nothing is possible. Now I come back here and change this one. Okay, so this way it will happen. I come here, and then so x1 now becomes 2, it calls n queens 2 comma 4, and I cannot place here, so this is also removed now. So I will make it clean because they are all gone now. In fact they are there, but they will be overwritten. Okay, so now here I cannot put because it is diagonal wise, column wise diagonal, and here I can put. So n queens x2 becomes 4. Now x3 it calls n queens 3 comma 4. So I come here, this place is fine for me. So I place here and x3 becomes 1. So I call n queens 4 comma 4. I cannot put here, I cannot put here, but I can put here. So this becomes x4 now becomes what? It becomes 3. And this way one possible configuration we get, and this is the only possible configuration in, because again I cannot place it here. So this way we can keep on going. We might get more possible configuration because this loop will now again we can try out here. So we can try out, but this way it will happen. So this is one of the configurations, and you can proceed with the algorithm further. So I hope you understand this backtracking problem. So we backtracked several times when there was no possible solution, and this is n queens problem. I hope you understand, and if you like this video, please subscribe to my YouTube channel and share this video among your friends.